To this unique person, ladies and gentlemen, CII Sorabji Godrej Green Business Center and Cement Manufacturers Association are proud to felicitate him for his exemplary contribution in promoting growth, sustainability in the Indian cement industry during his long and distinguished career. May I now request all the delegates. Ladies and gentlemen, the time we are waiting for has come. May I now request Dr. A.K. Chatterjee, Chairman, Convent Technologies Private Limited, and the personality who has been felicitated in Green Cementech 2017 to deliver his acceptance speech. Can you join me in welcoming Dr. Chatterjee for his acceptance?
Good evening to all of you. I think a lot has been said about me. I think so many good things at one point of time I had never heard earlier what I heard today. I am particularly thankful to CII and to CMA for bestowing me with this honor. It's a great, great honor, and I am really humbled to accept this. When I had received the invitation letter from Mr. Venkatgiri, I was traveling, and I had very little time in between. So I was about to send a polite regret to him. But before I could really sit down and write anything, I received a call from Mr. Jayaraman, who was really undergoing some treatment in a hospital because of some fall and some fracture or crack in his hip. He, in that condition, rang me up and said that please say no, I will not accept your no at all, and whatever may be the cost, you must see that you are here today. So that's how, I had to accept the invitation of Mr. Venkatgiri, and subsequently I received a communication from the present Secretary General of CMA, Mrs. Aparna Sharma, and I was overwhelmed, and I didn't know, how do I respond to such a great honor being bestowed on me. Well, I feel quite proud to belong to the cement fraternity. I feel proud primarily on account of the fact that if you look at all the man-made materials today, the cement industry globally is probably the largest. You leave aside the mining industry, of all the man-made materials, cement industry is the largest. It crossed 3 billion tons global production way back in 2009. It crossed 4 billion tons in 2014. And it's very realistically projected that 2019, the world would cross 5 billion tons. So can you imagine that this is a product which shapes the world? And if you look at what it makes in terms of the concrete, that's a material which is second to water that is consumed by the mankind. So I'm really very proud to belong to this industry and having done little bit here and there in this particular industry. My tryst with cement of course, started when I was a student in the then Soviet Union, now called Russia. And one day, my guide and professor dragged me into his chamber where I saw one microscope was there. And he took out a slide, started looking at that, and then told me, just look at what are these? Now, I saw for the first time in my life that how a C3S looks like under a microscope, how a C2S looks like under a microscope, and then he started, over a period of time, talking about structure-property relationship, that how, if we change the phase composition, what would happen to cement and what would happen to concrete. And it was so fascinating the way he put all that before me that somehow or other I got waded to cement. And now it's almost 5 decades that I have been involved with this industry in various capacities, in various places. My involvement with the Indian cement industry started when I joined the then Cement Research Institute, which is now known as the National Council for Cement and Building Materials. And that was again a fascinating period when I had really, got the good fortune of having extremely competent, good team to work with me in the field of cement technology. In fact, we were 3 individuals in the then Cement Research Institute. I was looking after the cement side. I had another colleague of mine, Dr. Malik, who was looking after concrete. And there was another gentleman with us, Dr. Mishra, who is no more. He has, expired. He was looking after the chemical engineering part of it. And this was the pyramid with which we were working at Cement Research Institute. Subsequently, of course, I had the very good fortune of leading the research in ACC, and this happened over a period of almost 25 years, that through various stages in ACC, I finally ended up in the boardroom of ACC. And during this period, I saw the cement industry moving from wet to dry. I saw the cement industry moving from a small kiln of 300 tons per day to 12,500 tons per day single kiln. This is the transformation of the cement industry which I have seen before my eyes over this period of time. I still recall my experience in Moscow. As a part of my education program, I was supposed to spend time in the operating plants. So one fine morning I was taken there. I had to live in that complex for almost 3-4 months. And during that time, they made me stand before something which I saw was 7-meter dia and 230-meter long. And I was flabbergasted to look at that, and that was a cement kiln. That was a cement kiln that was producing 1,000 tons of clinker per day by the wet process. And can you imagine, the size of the kiln was 7-meter by 230-meter, I still remember. So I passed through the different phases, and I had the good opportunity of really working in ACC with excellent team. When I had come to ACC research, there was nothing of cement research in ACC. You know, it was passing through the phase of the then Tariff Commission. Most of you are very young, you wouldn't know what the Tariff Commission was. But one thing I can remind you, that it's a government commission which used to fix the price of cement every year. They would come, they would assess, they would see what improvement you have done to your units and process, and if you have done some good improvement, and if your energy has come down, raw materials consumption has come down, then your prices will be fixed at a lower level. So this is how the Tariff Commission of Government of India used to work. And that was the time ACC thought it's not worth really doing cement research. So when I came to ACC, thanks to some of the very great personalities of ACC who decided to bring to ACC from the then Cement Research Institute, you know, I discovered that it's not a correct vision, and we must come back. ACC cannot live without delving into cement research. And that's how I ultimately succeeded, with the help of all my colleagues, to convert a cost center, which was CRS at that point of time, which was a cost center of ACC, to the tune of 3 crores at that point of time. And when I left ACC, that very place used to earn a revenue of about 100 crores. So that was the transformation. Around our research and development, we had developed, you know, a large number of discrete, separate activities of ACC combined into a single roof, and that was what Research and Consultancy Directorate of ACC was. And there, right from the geological exploration, I had a team of about 80 geologists working. I had an environmental management group, which, you know, KN just now talked about, and they were all fresh, young engineers, but they shaped up that entire business, that activity, that they would still cherish even today. Similarly, I had erection and commissioning group, which we went forward and did the erection of complete cement plants. So in a variety, concrete technology, we did a lot of things. I think just a little digression, that the first development of oil well cement indigenously was done from our research laboratory. We got the API certification, the American Petroleum Institute certification, for the first time. And then we had to prove it to ONGC that it really works. So I still remember that along with my colleagues, we were flown to Bombay High Platform, and for the offshore drilling, we had to use our cement and prove that that really works. And I still remember the kind of experience we had. We had never been on a floating platform. We never had seen a deep offshore well, what it would behave like for the cement. But it worked. It worked. Everything went off well, and ONGC was very happy with the development. I still remember the potent capability of our research station, that BHEL came one fine morning and asked us that, look, we need a cement for Antarctica, where BHEL was setting up a wind power generator. And they said that whenever we are trying this Portland cement, it really doesn't set, it doesn't work. So we said, yes, it would not work, but we will give you a cement which we would work. And we developed the cement which worked in Antarctica, and that entire quantity was produced at our research station. It was not a very large volume, and it was taken on the ship to Antarctica, and the entire wind power generator, the entire mast with the blades and all that, the foundation was laid with the cement that we had really sent from our research station to Antarctica. So there are many other, one thing that Kane mentioned, that, when the Air Force planes, the jets, they take off from a runway, from their underground bunkers, they come over that runway and then takes off, does the sorties and, things of that kind. Now, on our western side, what used to happen is that there were cluster bombing on our runway. And if there is a cluster bombing on the runway, then the jets cannot take off. So that's a preventive action that enemies used to take. So India used to import that cement and used to keep a stock of that for all emergency. And then the president of India, Abdul Kalam, was then the defense advisor, and he approached us, said that, look, India cannot depend for this strategic material on the foreign suppliers. So can you guys do something? And we developed that product, we replaced that, and defense started using the entire repair material. The condition was that within 2 hours of this bombing, the runway should get back to a condition where the fighter jets can take off. And that's what we did, and the jets did fly on the potholes and the things that we had repaired. And we were fortunate enough that before Abdul Kalam became president of India, he came to our research station. He spent almost a day at our research station, and he was so enamored that our research teams, I think, I still recall that they were so marvelous. That's why most of them are today occupying very, very important positions. It's not only K. N. Rao. You saw Philip. Philip was a very young chemical engineer working with me. Vasudevan sitting there, or Parlekar sitting here. They were all brilliant guys. Murumkar there working at the plant at that point of time. There are so many. And I still feel very proud that the teams were built up and the teams worked. They really came up as leaders. And today I feel so happy when I meet them in various places, various organizations, even outside India. I have met a lot of ex-ACC guys, doing a wonderful job. So that's a satisfaction which I always carry. When should I finish? You tell me.
As long as you want.
Maybe, I would not really bore you too long, but a few points pertaining to, I think, today's, discussions and which will go up to tomorrow evening, the greening of the cement industry. I think, all of you know, and probably it's carrying coal to Newcastle for me. Nevertheless, I must say that technology is generally divided into two broad categories. One part we say sustaining technologies, and the other part we say disruptive technologies. Sustaining technologies are generally adopted by most of the mature industries because they are, by and large, incremental in nature. And if you look at today, the cement industry, we blindly depend on the rotary kiln technology. Rotary kiln technology for cement making, irrespective of the scale of operation and all that, is roughly about 120 years old in the 200 years of history of Portland cement. Prior to rotary kiln, nobody knew that cement has to be produced in a rotary kiln. They were all static kilns. And today, we can't believe that anything else can work except rotary kilns. All the technological upgradation that has taken place, you start with the conversion of the wet to dry, you start with the onset of the preheated technology, you take the precalciner technology, everything has been reasonably incremental in nature. And many of those things, for example, preheated technology took 30 years for commercialization. The precalcination technology almost took 25 years for commercialization, despite the fact that they were fairly incremental in nature. And today, you look at that, you try to recall back. I am not really underestimating our discussions throughout the day. But you look back and think that all that we have discussed is further incremental improvement of our pyroprocessing systems. We have not even indirectly talked about the disruptive technologies. There were several disruptive technologies which people started working on in the 80s for pyroprocessing of cement. But for various reasons, they have not really seen the light of the day. For example, you take the fluidized bed clinkerization. It's a technology which started, with the Pisel process. And, it's a history today. Subsequently, even in early, this century, 2000, Kawasaki of Japan rejuvenated this. They ran pilot plants of starting from 2 tons per day to 20 tons per day. Then they did the entire supply of a white cement plant based on fluidized bed technology. They are able to really scale it up to a level of 3,000 tons per day. But beyond that, they're not able to go because the entire diameter of the system is getting beyond 8 meters. Now, these are the steps in which we need to intervene. We need to look at that, are there any disruptive ways of looking at and seeing that where we left in 80s or even 90s, can we rejuvenate these efforts and try to look at some of the totally new dimensions of the technology. I would say in the grinding side, a little better performance has happened with the help of the real innovators. But that's also adopted technology. Say, we talk about the roller press, which is, today a hallmark that we get the best energy performance in grinding. Now look at that didn't really happen in the cement industry. This entire system was really in the ceramic field and with the mineral processing industry, and which one fine morning, one of the major companies did lot of transportation work, that how this technology could be. Now, the path that has been laid and projected, either in the roadmap that India has prepared, basically India has prepared based on the EU roadmap, the European roadmap. We have done only tinkering here and there, but basically the European roadmap has been adopted for the Indian, industry per se, with a little bit of indigenization in the entire system. Now, you look at that and try to see that how the scenario will unfold up to 2025 first, and then to 2050. Now, this entire period, if you look at today, that by further improvement on the energy, further improve energy efficiency, and further improvement on AFR, what we are expecting, that if not 25, whether we can go up to even 20% by 2025, that's a very big step, very great achievement for the country. If you look at some of these things, in the overall effective reduction of the carbon dioxide, their relative proportion is very small. And what we really would depend on ultimately are the two major levers. One is the clinker factor, and the other is carbon capture and storage. Without carbon capture and storage, even today, if you add clinker factor to the other things like energy efficiency and also the alternative fuels and raw materials, if you look at that, you would find that still we will not be really achieving the level of carbon dioxide intensity, or for that matter, the total emission that we are talking about, if we reach a production level of, say, 550, 600 by million tons by 2025, or we go up to almost 1,300 million tons or 1.3 billion tons by 2050. Now, this particular aspect, if you have to really look at the clinker factor, then, it's not enough to talk about the blended cement as blended cement. You need to really distinguish the binary blended cements from ternary blended cements. And India has to now move towards the ternary blended cements, for which a standard has now been, that's not the ideal standard, that's not the best of standards, but something has happened in our country. And BIS has already come out with the composite cement standard. But you look at the entire industry today, most of the companies are engaged in getting a license, but not producing it. That's the kind of a scenario in which we are. And there are genuine reasons why the industry is not moving towards that. The genuine reason is obviously commercial in nature. And if you really don't see there is a profit for an industrial outfit to look forward to, that particular technology or that particular product will hardly see the light of the day. We have often talked about some incentives from the government. Those things in the long run do not work. India has got a brilliant example that I still remember when I was in CRI. We had moved the concept of mini cement plants to take care of small disjointed limestone deposits all over the country, and more so in the sub-Himalayan terrain. And fortunately, we could convince the then government, and a host of incentives were given to mini cement plant. And even today in CMA's statistics, they write some 356 mini cement plants. But in reality, hardly a few might be operating here and there. And this concept failed in our country primarily on account of the economics being unfavorable. So, be it the AFR, be it any other product technology, I think one thing we must carry in our mind that they need to be really cost effective. Until and unless cost effectiveness is seen very clearly, the industry's movements towards that may not be so easy to come by. That's one part of the clinker factor where the composite cements, is something on which we need to really focus on more seriously, not as a standard available and applying for license, but how do we commercialize this particular product, produce and commercialize, so that the effectiveness in the low carbon pathway could be obtained. Same thing is true with another product technology, which is a ternary blend that we are trying hard to really develop and introduce. That's, affectionately called LC3 technology. Basically, it's a limestone calcined clay Portland cement. And that's a product on which the amount of research work within the country and outside the country which has happened, that's enormous. That's enormous. We do not have that much of research and property data even for the slag cement or the fly ash waste Portland pozzolana cement that we have been really producing over decades. So some of these technologies need to be really looked at if we have to take recourse to clinker factor for achieving part of the low carbon pathway that we are talking about. Even then, I think it's very difficult to really accept that with these 4 or 5 things that we are talking about, essentially the energy efficiency part of it, the alternative fuels part, clinker factor part, still we would really achieve the kind of targets for the 2D scenario that has been painted so far. Unless we move towards really capturing the carbon. Now, carbon capture and storage is not a new concept. Already that's happening in the power industry outside India. And there are many pros and cons of doing the carbon capture and storage. In fact, the ICRA, many of you may know, may not know, that there is an European Cement Research Association called ICRA. And they have done quite a bit of work in the cement carbon capture and storage. And apparently it seems that if you take into account the investment required for adoption of this technology and also the running costs that you will have to really incur for this, a product like cement will not really be in a position to support. Or in other words, the carbon capture and storage as an avenue have got also very limited potential for the cement industry. So what's the option? The option is that carbon capture is possible. You know, the technology is not something new or unknown or unpracticed. But you don't really think about storing that carbon dioxide, but you do two things. Either you transform that or you use that. Now, which we say is the change from CCS to CCT or CCU. Now, what is CCT? CCT is that can I recycle the entire carbon dioxide back into the system as a fuel? Some work has been carried out, most of you might be aware of that, that's the algal growth for really utilizing this. But many bioreactors have been designed, fairly pilot-level experiments have been carried out, but the algal growth route apparently has got a lot of impediments to overcome. So it's not to be discarded, but needs to be re-examined in all its perspective to really see whether further progress could be made. But parallelly, essentially from the space research, what is coming up is highly potential. That's the electrocatalytic reduction of carbon dioxide. And this electrocatalytic reduction today is possible with nanoporous silver particles. And this is such a potential area where you can convert this carbon dioxide to carbon monoxide, and ultimately you can flow back as a fuel into your system, or you can use that as a feedstock for getting into a variety of chemicals, production. Now, some of these things need to be really looked at very seriously today. And if I see today the entire innovation and resource development organizations on channels have not really looked at the carbon dioxide capture and reuse area. We still quote a few American companies, or a few Australian companies to prove this point. But the Indian talent and the Indian brain and the Indian research infrastructure has not moved into this area at all. And I think it's high time. And maybe an organization like CII, CMA could be the pushers and take the entire innovation infrastructure of India also into a new direction for the low carbon pathway that we are talking about. Well, I mean, one can go on, talk about various things, but I must limit some of the things. Only another, I think before 6 o'clock I must finish. The last point I thought I must make, it's about the sustainability that we have talked about, and particularly the raw materials conservation. A lot of apprehension has been really expressed, and which is genuinely true, that if the cement industry grows at a pace that is projected, or sometimes it has happened, sometimes due to cyclicity it's not happening, but still India, of course, would need, with its 1.25 billion population, a very large proportion of cement. Without that, the country will not really prosper as we wish it to be. Now, if we have to do that, yes, the limestone as a resource needs to be really found out, as long as we are on the path of the Portland cement that we are talking about. And all projections indicate that there is no possibility that we would discard this Portland cement way in another maybe 50 years. There is no substitute. So therefore, this is going to stay, and if we have to really keep on with this industry, we will also have to live with the concerns of limestone and what we need to do. There, of course, there are various issues. One is that a lot of limestones are today covered under the restricted zones, like forested area or in the biospheres and things of those kinds. Now, how to handle those things is a million-dollar question, and those things will have to be addressed over a period of time. But more than that, nearer to our industry, I have personally seen, and I have really instigated some of the industrial units to look into that they have got fairly large reserves of limestone, but it's a high sulfur-bearing limestone. So what happens? That there is a cutoff point for the sulfur, for the limestone to be mined and used. If you go beyond that cutoff point of sulfur in the limestone, you face a large number of operational problems, quality problems, and things of those kinds. Now, if you look at the chemistry of materials, some of these high sulfur limestones, one can think about using, if you can really kind of arrest this sulfur in certain forms or phases which are unreactive and will not really pose problems in your system. Now, these kinds of research. We started in ACC in 90s, but again it has slipped back and we are not doing much. I'm trying to instigate many other organizations to look at that. And same thing is true for the alkalis. There are limestones, fairly large reserves in our limestones. Again, the alkalis are high and sulfur is not very high, and therefore the alkali-sulfur balance you cannot really ensure, and you do not know what to do. So safest is you tell your mining department that don't mine limestone if the alkali percentage is higher than X. And that's how the high alkali portion of the limestone remains in the ground. Same thing is true with the magnesia content. We have got enormous high magnesia limestones known, and many of the cement plants have got their quarries containing these materials, but we do not know how to use those things. And nobody talks about that. Everybody talks about the problem of the limestone resource and how will the growth be sustained. I think many of these things need to be really reopened, relooked, re-examined in a broader perspective. Same thing is true, I think Ken Rao or Philip, somebody mentioned, today about the high belite cement. That's again another avenue for conservation of, raw materials. And high belite cement is again not a space technology. High belite cement has been in production in India in, over decades. We had in ACC our Lakeri plant. We had our, unit in Tamil Nadu, with this kind of product, where we had belite content in the cement, somewhere close to about 40% or even beyond. And this kind of cement, in the long run, gave us strength levels on 28 day somewhere beyond even 70 MPa. Now, we refuse to look at some of those things purely because of the commercial pressure. Because the construction industry insists on removing the formwork within the shortest possible time, they want to do less of curing over a period of time. They always insist on that give us an high early strength cement, and we in the industry keep on dancing to that tune. So in one of the CSI, means Cement Sustainable Initiatives meeting, which I happen to be there, I have said that what are the barriers? And in that I have mentioned that, for example, this high belite cement, you can certainly introduce in the country, provided here there is an intervention from the authorities, and they say that India or the Indian industry must produce at least 10 or 15% of their total production in the high belite form. Then the entire picture will start getting corrected. Today what's happening, our education of cement application is so poor in our country that requires a very strong initiative to really get into. That mode we are not talking about. We are not talking about the education part at all. Today, if you look at India, with a production capacity of 425 million tons, which is likely to go to 550 or 600 million tons in a matter of another decade. You know, cement technology is still taught primarily by 3 or 4 institutions as a part of ceramic engineering. It's only 1 or 2 separate institutions are trying to really come into the cement technology or cement engineering. Now, look at the fallacy. The ceramic engineering and the ceramic industry, with all its, different products and perspectives you look at, this will be much smaller than the cement industry alone. Now, all the universities, they will teach ceramic engineering, but there will not be any introduction of the cement engineering part of the course. So somewhere, I think, along the line in the industry, we have been either very protective for ourselves, or we have not taken certain bold initiatives, and we have not really tried to correct the image of the industry as a progressive, forward-looking, environmentally friendly kind of an industry. And that image needs a correction. It's almost evident that we need to get into a mode of education. We need to really educate the consumers and users that, look, until and unless, you see a product which is certified or approved by the CII scheme, you should not really use that. Or you should preferably or preferentially use the product which is certified. Now, all this education is not coming through. So, few, recognitions and things of that kind will not change the scenario. It's a massive movement of education, massive movement of bringing up the subsequent generations of engineers, technologists in our country with full understanding that will bring in the kind of a low-carbon pathway that we are talking about, than a few discrete technologies and some a kind of a sustaining incremental developments in those technologies. Sorry if I've hurt anybody's thinking or perceptions or concepts by being probably too radical in some of these things, but I, for one, believe that ultimately we will have to move towards some of the directions that I highlighted today. Anyway, this is, by the way, an opportunity taken by me to talk about the subject, and I deviated from the very fundamental thing that I have been greatly honored by CIA and CMA, which I will ever remember. Thank you very much, ladies and gentlemen.